Hey there folks, let's talk EDM or Electrical Discharge Machining. Think of it like sculpting with lightning. We use a controlled spark to erode metal with incredible accuracy. This process is a game changer for making complex parts in industries like aerospace and medical.
Now, EDM might seem complicated, but don't sweat it. With the right steps, even a beginner can master this technology. We're talking about getting that perfect setup, understanding the machine's quirks, and knowing how to troubleshoot when things go sideways. This isn't rocket science, but precision is key. We're dealing with tiny sparks that can make or break your project.
So let's dive into the nitty-gritty of setting up your EDM machine like a pro. Get ready to unleash your inner machinist.
Alright, before we fire up this bad boy, let's talk shop hygiene. Just like a surgeon preps their operating room, we need a clean and organized workspace. Trust me, a little elbow grease goes a long way in preventing costly mistakes and downtime.
First things first, grab a shop rag and wipe down the machine. Get rid of any chips, dust, or stray tools. We don't want any contaminants messing with our precision.
Next, check the dielectric fluid. This stuff acts as an insulator and coolant during the machining process. Make sure the fluid level is topped off and free of debris. Think of it like the lifeblood of your EDM machine.
Now take a look around. Is your tooling organized? Are your work-holding devices within reach? A well-organized workspace is a productive workspace.
Now let's talk about the guest of honor, the workpiece. This is the metal piece we'll be shaping with our EDM magic. Securing it properly is crucial for accuracy and safety. We don't want any unexpected movements during the process.
Depending on the size and shape of your workpiece, you'll need the right work-holding device. Vices, clamps, and fixtures are your best friends here. The key is to ensure a rock-solid hold without distorting the workpiece. Remember, we're going for precision.
Once you've got it clamped down, double-check the alignment. Use a dial indicator or other precision measuring tools to ensure it's perfectly positioned. Even a tiny misalignment can throw off your entire machining process.
Now, for the business end of things, the electrode. This is the tool that carries the electrical discharge and erodes the workpiece. Choosing the right electrode material is essential for achieving the desired results.
The two most common electrode materials are graphite and copper. Graphite is great for intricate details and fine surface finishes. It wears down faster but offers excellent detail.
Copper, on the other hand, is tougher and lasts longer, making it suitable for roughing and large cavities. Consider the complexity of your part, the required surface finish, and the machining time when selecting your electrode. Don't hesitate to consult machining data or talk to your tooling supplier to get the best fit for your application.
Section 5, dialing it in. EDM Parameter Settings. With the workpiece and electrode in place, it's time to configure the EDM machine's parameters. These settings control the electrical discharge, essentially fine-tuning the spark that does the heavy lifting.
Key parameters include on time, off time, servo voltage, and discharge current. On time is the duration of the spark, while off time is the pause between sparks. Servo voltage controls the electrode's movement, and discharge current determines the intensity of the spark.
Each parameter affects the machining speed, surface finish, and electrode wear. Finding the optimal settings is a balancing act.
Too much power can lead to a rough finish, while too little power can result in slow machining times. Start with conservative settings and gradually adjust them based on the results you observe.
Section 6. Flush it out, keeping it clean. As the EDM process kicks off, you'll notice tiny metal particles accumulating in the dielectric fluid. This debris, if not properly managed, can interfere with the spark, leading to inaccurate machining and even damage to the workpiece or electrode.
That's where flushing comes in. Think of it like a continuous car wash for your EDM process. The dielectric fluid, typically deionized water or oil-based, flows through the machining zone, carrying away the debris and keeping the process running smoothly. There are different flushing methods, including jet flushing, suction flushing, and through electrode flushing. The choice depends on the application and the EDM machine's capabilities. Ensure your chosen method effectively removes debris and maintains a clean machining environment.
Section 7. Test drive the trial run. Before you let your EDM machine loose on the final workpiece, it's crucial to run a test cut. Think of it like a dress rehearsal before the big show. This step allows you to verify your setup, fine-tune parameters, and avoid costly mistakes on the actual part.
Choose a scrap piece of material similar to your workpiece and secure it in the machine. Program a simple geometry like a slot or a hole and run the EDM process with your chosen parameters. Carefully observe the machining process, monitoring the spark, the flushing, and the surface finish. After the test cut, inspect the results. Is the geometry accurate? Is the surface finish acceptable? Are there any signs of abnormal wear on the electrode? Based on your observations, make any necessary adjustments to the setup or parameters before proceeding with the final machining.
Section 8, Staying Sharp, Monitoring and Troubleshooting. Even with a perfect setup, things can still go wrong during the EDM process. That's why it's essential to keep a watchful eye on the machine and be prepared to troubleshoot any issues that may arise.
Listen for any unusual noises coming from the machine, such as excessive sparking or grinding. Monitor the dielectric fluid for discoloration, which could indicate contamination or overheating. Check the control panel regularly for any alarms or error messages. Common issues include electrode wear, arcing, and short circuits. Electrode wear is normal, but excessive wear can affect accuracy. Arcing occurs when the spark jumps to an unintended location, causing damage. Short circuits happen when the electrode makes contact with the workpiece, disrupting the process.
If you encounter any problems, don't panic. First, try to identify the root cause. Consult the machine's manual, online resources, or your tooling supplier for guidance. Adjust parameters, replace worn electrodes, or seek professional help if needed.
Section 9, Finishing Touches, Inspection and Cleanup. Congratulations, your EDM process is complete and you've successfully machined your workpiece. But before you call it a day, there are a few finishing touches that require attention.
First, carefully remove the workpiece from the machine, ensuring not to damage the delicate features. Inspect the machined areas for accuracy, surface finish, and any signs of damage. Use precision measuring tools to verify critical dimensions. Next, it's time for cleanup. Dispose of the used dielectric fluid responsibly, following safety guidelines. Clean the machine thoroughly, removing any debris or residue. Store the electrodes properly to prevent damage or contamination. By following these steps, you'll ensure the longevity of your EDM machine and the quality of your future projects. Remember, precision is a journey, not a destination. Keep learning, experimenting, and pushing the boundaries of what's possible with EDM.